Hey everybody, so today we're going to be doing the review for our test that's coming up on linear functions. More specifically, linear functions including direct variation and finding the intercepts, both the x and y, from linear functions. So the first two questions on here, the first two problems, say to graph the following pairs of line and then determine if they're parallel, perpendicular, or oblique. Now remember, parallel lines never touch. They're straight lines, like the two L's in parallel, where perpendicular lines cross, forming a perfect T, or X. And oblique lines are going to cross, but they don't have that perfect 90 degrees like a perpendicular one does. So let's go ahead and graph this first one, since it's already solved for y for us. We always start with our y-intercept. In this case, that's -1, so I put a dot there. I then look at my slope, which is 2. Since it is positive, I'm going to go up 2 and over 1. And I'm going to follow that pattern until I run out of space. Once I run out of space, I'm going to go the opposite direction. In the opposite direction, I'm going to go down 2 and to the left 1. Again, I do this until I run out of room. Once I am done, I'm then going to connect all these dots and then draw an arrow at the end to show that it's going to go on forever. Let me zoom in for y'all. There we go. Now that next equation right underneath it is not solved for y, so we're going to need to solve it for y. So I can do that, but the 2 is attached to it. So I need to get rid of that 4x, and it's positive. So I'm going to subtract 4x here. But the rule is, what you do to one side, you have to do to the other. When I do that, you have 2y is equal to, I cannot combine those two terms because the -8 does not have an x. So it's -4x minus 8. Now, attached to that y is a 2. Since it's a number and a letter side by side, they're multiplying, so I need to do opposite, which is divide. But again, the rule in algebra is what you do to one side of the equal sign, you have to do to the other. So I'm going to divide everything by 2. And I'm just going to write my equation right here. So y is equal to a -2 over 1 x minus 4. Now, if I want to graph that equation, I always start with my y-intercept. In this case, that's a -4. 1, 2, 3, 4. Put a dot there. My slope is negative, so I'm going to go down 2 and to the right 1. When I run out of room, I'm going to go the opposite direction over here. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, until I run out of room, and then I again will connect all these dots the best that I can. Now, if we were to look at these lines, we notice that they do cross, so it's not going to be parallel. So let's look at our slopes. Our slopes for these two lines is a -2 over 1 and a +2. So it's either going to be perpendicular or oblique, but we know perpendicular lines have a flip of the slope. You flip the slope, the fraction, and you change the signs. Well, we went from a positive to a negative, but we did not flip it. If this was 2, this would have to be a 1 over 2. Which it's not. So the correct answer for this is oblique. Now let's do number 2 together. So we'll go ahead and graph this first one. We'll graph that in green. So starting with the +3, I'll put a dot there. My slope is a +2, so I go up 2 over 1. Now I'm going to go down 2 over 1 to complete it on the other side. like so. When I run out of room, I will connect my dots. And I'll use a ruler for that. Don't forget your arrows. Now let's do the other one. We notice that this equation is not solved for y for us, so we need to solve for y. The 5 is attached, so we need to get rid of that 3x first. So I'm going to subtract 3x on both sides. That goes away. So I have 5y is equal to, cannot combine those two because the 15 does not have an x. Now, the 5 and the y are side by side, so we know that's multiplication, so I need to divide by 5 here, here, and here, because what you do to one side, you have to do to the other. So I'm going to write this out simplified the best that I can. That's negative 3 over 5 as my slope, the number in front of x, and my y-intercept is a positive 3, because that is what this reduces to. Alright, so let's graph this one. I start at a positive 3. Put a dot right there in the middle. My slope is negative 3 over 5, so I'm going to go down 3 and to the right 5. And put a dot there. Oh, is that 5? 1, 2, 3, 4. Oh, right here. Not that one. Then I will continue that pattern going the opposite direction. Up 3, 1, 2, 3, over 5. 1, 2, 3, 4, 5. And now I just gotta make sure I connect the correct dots. Like that. Draw an arrow at each end. And now where they're crossing again, so we know it's not going to be parallel. So we need to look at the slopes. We have a positive 2 and we have a negative 3 over 5 as our slopes. They have nothing in common, so again our answer for this one will be oblique. Because they cross, but the slopes have nothing in common. Alright, let's go ahead and move on to number 3. Now this one you have a word problem. Go ahead and pause the this video if you need to read it, or read it on your paper. So it's a multi-step problem. You have A, B, C, and D that you need to answer. The first one says they want you to sketch this function right here. So if you're going to sketch it, you're going to start with your y-intercept. That is always going to be your starting point. So 30, we notice that the y is going by 10, so 30 is going to be right there. Our slope is 25, so I'm going to go up, that's 10, 20, and 25 would be right here in the middle, and over 1. I'm going to do that again, that's 10, 25, right there, that's 10, 25, so it's in the middle, 10, 25, right there, 10, 25, 10, 25. And then I run out of room. So it's a little bit different just because we're not going by ones and the 5 isn't marked there for us. So you're going to have stuff that's in between. So there's the graph. So now let's look at part B, and B is asking us, they want to know what is the temperature, which we know is our y-axis, of the rocks at the depth of 4 kilometers. So I find 4 on the x-axis, and I'm going to go up until I hit the graph, and then I'm going to go across, which will be right here. And on this, I'm going to see that it's 130 degrees Celsius, so that's going to be my answer. Now part C says, what does the y-intercept mean in this context of the problem? Well, here's my y-intercept, and according to this word problem, that is going to be 30 because it's in our equation. And this is going to be the starting temperature. And I'll write this. The starting temperature at 0 depth. Because if we look at the x, it is at 0 kilometers. That's how deep it is. Now, the next one, the last part of this question, asks what is the slope of this function and what does it mean? Well, we have points and we have our equation. We know if it's set up y equals mx plus b, the number in front of the variable is always going to be our slope. So I don't even have to find it, but if I wanted to find it here, I could pick 2 points, do rise over run. I went up 25 and I ran 1, so my slope would be 25 over 1, which is exactly what our equation said our slope was going to be right here. So what is the slope? 25. And what does that mean? It means that, I'm going to move this up so you can see it, that the temperature, and I'm just going to put temp for temperature, increases 25 degrees Celsius for every 1 increase in depth. Your y over your x. You always want to say what's going on in your y, how much you're increasing or decreasing by, over how much whatever your x is talking about. So that's 3. Let's go ahead and move on to number 4. And this is where we start our intercepts. We have 3 problems for number 4. All you need to do is find your intercepts, the x and the y. Now remember, for your x-intercept, you have to have a 0 for your y, and for your y-intercept, you have a 0 for your x. Just like that. So when we're looking at a table, if I'm trying to find my x-intercept, I'm going to write it as an ordered pair. I know I'm going to have a 0 there automatically in the y spot. So when I look at my table, all I need to do is find a 0 in the y column and find out what my x is. In this case, 5. When I'm looking at the y-intercept, I need to find an intercept, or I need to find a 0 in the x spot, like right here. So it's 0, comma, and the y value is 3. Alright, let's look at that graph now. So for this graph, you have an x-intercept, again, 5, oh, I'm sorry, not 5, we don't know what that number is yet, some number, comma, 0. Now here's my x-axis, and this is my y-axis. I'm going to look at this graph and see where it crosses the x-axis. And to me it looks like it's going to be at a -6. So I just need to fill that in there and I'm done. Now for my y-intercept, I'm going to do the same thing but for the y-axis. I know my 0 is going to be in the x spot, and all I need to do is find out where exactly it crosses right here. So that's 1, 2, 3, 4, +5. And I'm done. Now for equations, we have to do a little bit of work, but it's not too bad. All you need to do is make sure you know where to plug in your zeros. So we'll do the x-intercept first. So for the x-intercept, we know we're going to have a 0 in the y spot. So I'm going to rewrite this whole equation, but instead of y, I'll have a 0. So that is 7x minus 3 times 0 is equal to -21. Just like that. The -3 times 0 goes away. So I will have 7x is equal to 21, and that can be reduced to, I'm sorry, it's a negative 21. So x is going to be, when I divide by 7 on both sides, a negative 3. So I just need to plug that into my equation right here, and I'm done, or into my point. Now let's talk about the y-intercept. It's going to be the same thing, you just plug in a 0 somewhere else. And that somewhere else is going to be for x. So you have 7 times 0 minus 3y is equal to negative 21. Oh, I'm running out of room here. That's going to go away. Negative 3y is equal to negative 21. I'm going to divide each side by negative 3. And I know 2 negatives is going to give me a positive answer. And that positive answer is 7. Just plug that into the point, and I am done. Alright, we're almost halfway done. Or we're pretty much halfway done, actually. Because these next problems are going to go pretty fast. Alright, so let me zoom in so we can see this problem. Number 5. It says, what is the 0 of this function? Now 0 is just another way of saying x-intercepts. So it's already even labeled for us, our x-axis right here. All I need to do is figure out what number that is. And that's labeled for us also. So we always write it as an ordered pair. If we're talking about an x-intercept, you have a 0 in the y. And your x is 3. And we're done. Now number 6. Which situation can be best represented by a linear function? Well, we had a foldable on it, and it was either yellow or orange depending on what class you were on, what class you're in. And in that foldable under situations, it said for words to look out for were area and volume. Area is always going to give us something squared, and volume will always give us something cubed, or raised to the 3rd power. And neither one of those are linear. So now we've narrowed it down to B and D. Well, the numbers of germs doubles every hour. Anything that doubles or triples or quadruples over time, that's going to be an exponential. Something like that. So that's definitely not linear. And in that foldable, it told us that perimeter and circumference were key words to let us know that that would be linear. So you just got to know your words, got to know your definitions. Okay, guys? Look over your foldables. Now this word problem, let me zoom out so you can see all of it. It's a very good one. It tells you everything you need to know for direct variation, which is why it is here, and you might just see it again somewhere else. So we have, these are our keywords, our key terms that we're going to use to fill in the blanks. It's our word box. So it says direct variation is a linear relationship written in the form y equals kx. That is our equation. That is our formula. When we graph it, it will always pass through the origin, right in the middle. In a direct variation, the constant of variations, k, is also known as our slope. It can be a positive slope or a negative slope. Because the graph of a direct variation always passes through the origin, so if you didn't know that, it said it again right here, it must have a y-intercept of 0. When determining if a function is a direct variation from a table of ordered pairs, we can use a ratio blank, also known as the constant of variation. that is y over x. So that wasn't so bad. Let's finish up that last page with the last 3 problems. And we are done. And all 3 of these are direct variation problems. So, we're actually going to start with number 10. And then we'll work our way up. Anytime we have varies directly or proportionally, that is always like our dependency statement where the y depends on the x. And that's going to help us find our constant because we always use that, like our paragraph just told us, our ratio. So if A varies directly with B, so the first one goes on top, A over B, and B is equal to 6, so now I'm just filling in with numbers, and A is equal to 12. Well, we know that fraction can be reduced automatically, and that'll be 2 over 1 is our K. Then find X when Y is equal to 135. Okay, so we're going to use Y equals Kx, and we know our K is 2. It says to find X, so we don't know what X is yet, but Y is going to be 135. So we're just filling it in, substituting the answers or the numbers that they gave us for these variables. Well, 2 and X are multiplying, so I'm going to divide by 2 to cancel that out. But what you do to one side, you have to do to the other. So when I divide that, you will get X is equal to 67.5. And that's what they wanted. So we're done with that problem. You just have to remember, whatever goes first, whatever they're talking about first goes on top, and whatever they're talking about last in your little sentence goes on bottom. So let's look at number 9. The amount of money Jesus earns working varies directly, so there it is again, part of our dependency statement, to the number of hours he works. So if I'm writing my constant y over x, I know that the number of hours worked is at the bottom, where the amount of money is on top. If he earns $16 for 2 hours of work, how many hours will it take to earn $400? So we have to find our K, so we can simplify that down to 8 over 1 as our K. So they're giving us a money amount, they're giving us our Y. So we're going to write it in our Y equals KX formula because we know K is now 8 and Y is now 400. We're looking for X, how many hours? So we're going to divide by 8 on both sides so we can get X by itself. And when we do that, we're going to get X is equal to 50. So that's 50 hours, and they asked us for our constant, and we found that earlier. That was 8. Alright, last problem on our review, guys. Ready? Now this one says the number of raccoons Y living in a 10 square mile area varies directly with the number of coyotes. So they were nice enough to give you what X and Y was going to be. So K is equal to Y over X, and that never changes. In this case, raccoons over coyotes. So, this says there are 12 raccoons living in an area with 3 coyotes. So that's going to be 12 over 3, which is equal to 4 over 1 as our K. Now, we're going to use that K to help us find out how many raccoons, which are our Y's, live in the area when there's 15 coyotes, which is our X. So Y equals KX. We know our K is 4. We just found that out. They gave us 15 for our coyotes, which was X, and we need to find out how many raccoons, Y, there are. So Y is going to be equal to, or the number of raccoons is going to be equal to whatever 4 times 15 is, which we know is 60. So there will be 60 raccoons. Alright guys, so look over these notes. You have a test this Thursday. Good luck.